The ocean pattern responsible for some of the most extreme weather years on record just moved faster than almost anyone forecasting it expected. The consequences of that speed are already rippling out toward the shores of Britain months before anyone thought they would. Scientists tracking this year's El Niño event say the ocean didn't just strengthen on schedule. It leapt straight past the threshold that defines a so-called Super El Niño, and it did so in the middle of summer, months before this kind of event usually reaches anything close to its peak. Today we're going to break down exactly how fast this thing intensified, why that speed has researchers genuinely surprised, what it means for the rest of the planet, and what it actually means for weather here in the UK as we head toward autumn and winter. Let's start with what El Niño actually is, because the mechanism matters enormously for understanding why this year is different. El Niño is the warm phase of a naturally recurring climate pattern called the El Niño Southern Oscillation, a cycle driven by shifting sea surface temperatures across the tropical Pacific Ocean. Scientists track its strength using something called the Nino 3.4 index, which measures how far above or below average the sea surface temperature sits, i.e. a specific stretch of the central and eastern Pacific. When that anomaly climbs above 2 degrees Celsius, researchers classify the event as a Super El Niño, a threshold that's only been crossed a small handful of times in the entire modern climate record. Here's what makes this genuinely unusual. Coming into June, the Nino 3.4 anomaly sat at roughly 0.7 of a degree above average, a fairly ordinary reading for an event still in its early developmental stage. Within about 5 weeks, that number had more than doubled, climbing past 1.4 degrees. By the middle of July, the weekly reading had pushed even further, up to 2.1 degrees above average, comfortably crossing the Super El Niño threshold. Oceanographers have a specific term for this kind of jump. They call it rapid intensification, and the pace of this particular surge is what's caught forecasters off guard. El Niño events typically build gradually across many months, usually reaching their strongest point sometime in December. This one effectively arrived at super-strength territory in the middle of summer, months ahead of when the textbook pattern says it should. Think about what's actually driving that speed underneath the surface, because this isn't just warm water sitting on top of the ocean. Researchers using satellite altimetry have detected a significant rise in sea level across the central and eastern Pacific, a signal tied to what's known as a Kelvin wave, an enormous subsurface pulse of warm water sliding eastward beneath the ocean's surface like a slow-motion wave rolling toward the far side of a bathtub. As that wave surfaces and spreads, it dumps an extraordinary amount of stored heat directly into the atmosphere above it, and that heat is precisely what's been accelerating this event faster than the models initially predicted. NASA researchers monitoring this Kelvin wave describe it as one of the clearest early warning signals available for a strengthening El Niño, and the size of this particular pulse is part of why forecasters have been revising their outlooks upward, not downward, as the summer has progressed. It's worth understanding why that subsurface heat matters so much more than a simple warm patch of ocean would. Once that heat surfaces and starts feeding directly into the atmosphere above it, air pressure begins dropping across the central Pacific, while rising over the western Pacific near Indonesia and Australia, a seesaw pattern scientists have tracked for decades. That pressure shift doesn't stay contained near the equator. It reorganizes the position of jet streams thousands of miles away, which is exactly the chain reaction, known as a teleconnection, that eventually links a warming patch of open ocean near the equator to a stormy November in the North Atlantic. The 2023 to 2024 El Niño, the most recent comparable event before this one, followed that same basic playbook, and researchers have already flagged its behavior as one of the closer analogs for how this year's teleconnections might unfold, even though this event is on track to significantly exceed it in raw intensity. To put the scale of this in context, the strongest Super El Niño ever recorded, back in 1982 and 1983, peaked at an anomaly of 2.69 degrees. Current model forecasts now put the median expected peak for this event at around 3.1 degrees, which would make it the strongest El Niño ever measured by this metric, surpassing even the historic 1997 to 1998 event that triggered devastating droughts, floods, and heat waves across multiple continents. Scientists studying the historical record have also pointed to the Super El Niño of 1876 to 1878, an event so severe it contributed to catastrophic famines across Asia that claimed tens of millions of lives, as a sobering reference point for just how disruptive an event at this intensity can become when it interacts with vulnerable food and water systems. If you're finding this breakdown useful, go ahead and hit that like button. It genuinely helps climate coverage like this reach more people who want to actually understand what's happening rather than just see another scary headline. There's an important distinction worth making here before going further, because reaching every region on Earth experiences peak impact simultaneously. El Niño's effects typically lag behind the ocean's actual temperature peak, often by a few months, since it takes time for that released heat to fully reshape global atmospheric circulation. Researchers have also flagged something they call the rising tide effect, the idea that this El Niño isn't developing in isolation. It's stacking directly on top of oceans that are already warmer than at any point in the instrumental record because of long-term human-driven warming. Climate scientists studying this event have said explicitly that the world has never experienced a strong or very strong El Niño against a backdrop this warm before, which means some of the impacts researchers expect later this year and into 2027 could genuinely be unprecedented, rather than simply a repeat of past events at a larger scale. So what does an event like this typically produce globally? El Niño reliably increases the risk of drier conditions across Indonesia, Australia, India, and parts of Central and Equatorial South America, while pushing wetter conditions into the southern United States and other pockets of South America. Forecasters are already watching for Elevate D wildfire risk building across South America and Southeast Asia later this year, with the most severe fire activity in the Amazon typically lagging the peak of the event by roughly a year, meaning the second half of 2027 could be the period to watch most closely there. Agricultural forecasters are watching just as closely, since shifts in monsoon rainfall across South and Southeast Asia can directly affect staple crop yields, and past strong El Niño years have coincided with measurable disruption to global food and commodity prices. There's an unexpected upside buried in this pattern too. A stronger El Niño tends to increase wind shear across the tropical Atlantic, conditions that are generally hostile to hurricane formation, and forecasters have already begun trimming their storm predictions for this Atlantic hurricane season as a direct result. Meanwhile, the sheer amount of heat this event is releasing into the atmosphere has already pushed 2026 toward becoming one of the warmest years ever recorded. And researchers now put the odds of a new global temperature record at roughly 1 in 3, a figure that's nearly doubled over just the past few months as the forecasts for this event have strengthened. Now let's bring this back to Britain specifically, because this is where the story stops being abstract for anyone watching, from the UK. El Niño's influence on British weather has always been more indirect than its influence on the Pacific itself, since the UK sits in a complicated mid-latitude zone shaped by multiple overlapping climate drivers at once. But the mechanism connecting the two is well understood. Warming in the tropical Pacific reshapes something called the Walker circulation, a massive loop of rising and sinking air that stretches across the equatorial Pacific, and disturbances to that circulation ripple outward through the jet stream, the fast-moving river of air high in the atmosphere that steers weather systems across the Atlantic toward Britain. When El Niño shifts the position and strength of that jet stream, it can meaningfully alter the storm track that ultimately determines whether the UK gets a mild, wet winter or something colder and more unsettled. Historically, the Met Office notes that El Niño winters tend to bring an increased chance of milder, wetter, and windier conditions across the UK during the early part of winter, typically November and December, as stronger westerly winds pull more Atlantic weather systems directly across the country. That pattern doesn't always hold through the entire season, though. Meteorologists studying past strong El Niño years have also flagged an increased chance of colder spells arriving later, typically in January through March once the atmospheric pattern shifts again, the winter of 2015 into 2016, which coincided with a strong El Niño, is one of the clearer recent examples of this dynamic in action. When a run of powerful Atlantic storms, including storms Desmond, Eva, and Frank, brought record-breaking rainfall and serious flooding to parts of northern England, Wales, and Scotland within just a few weeks of each other. Researchers studying that winter have connected the unusually active storm track directly to the El Niño pattern in place at the time, which is exactly the kind of setup forecasters are now watching for again, given the strength of this year's event. Adding another layer to this year's picture, researchers tracking the stratosphere have identified a significant wind reversal currently descending through the upper atmosphere, a shift that, combined with the strengthening El Niño and the state of the polar vortex, forms what some forecasters are calling a 3-par-T driver of this winter's jet stream behavior. Depending on exactly how that combination plays out, it could either reinforce a blocking pattern of high pressure over Greenland and northern Canada, which tends to send colder air spilling into the UK and Europe, or keep the door open for the milder, stormier Atlantic pattern typical of earlier El Niño winters. Scientists are also careful to point out that El Niño is only one voice in a much larger conversation over the UK's weather, since patterns like the North Atlantic Oscillation and the quasi-biennial oscillation can just as easily reinforce or override its influence depending on how they line up in any given year. For comparison, the 1997 to 1998 Super El Niño, the closest historical analog to what's developing now in terms of raw intensity, brought a mix of significant storms and unusually mild stretches to the UK, underscoring just how much variability even a single strong event can produce here, compared to its far more predictable effects closer to the equator. If storm and climate coverage like this is something you want more of as this event develops, subscribing means you'll catch the next update the moment new data comes in. Bringing this together, what makes this year genuinely different isn't just the raw strength this El Niño is forecast to reach, it's the speed at which it got there. An event that models expected to build gradually across the second half of the year instead surged past the Super El Niño threshold in the middle of summer, driven by an enormous pulse of subsurface. Heat that forecasters are still working to fully characterize. Scientists studying past events caution that with only a handful of comparable Super El Niños on record, confidence about exactly how this one will unfold and how long any resulting changes might persist remains genuinely limited. What is clear is that an event stacking on top of record warm global oceans is capable of producing effects that don't perfectly match the historical playbook, from drought and fire risk across multiple continents to a real chance at a new global temperature record within the next 2 years. For Britain, the message isn't panic, it's attention. The direct link between Pacific ocean temperatures and a rainy November in Manchester will never be simple or perfectly predictable, but the atmospheric chain connecting the two is real, well understood, and actively being reshaped right now by a stratospheric wind shift layering on top of one of the fastest developing El Niño events ever recorded. As autumn approaches and the UK's seasonal outlooks firm up over the coming weeks, this is exactly the kind of pattern worth watching closely. Because an ocean event that already moved faster than anyone expected once this year has every reason to keep surprising forecasters as it heads toward whatever peak it ultimately reaches.